That's the one I needed to press. All right. So yeah, once again, excuse me, still admitting people. All right, let's get going. All right, so once again, bats are our largest group of mammals. So let's talk about bats in more detail. This is the bat range. Bats are pretty much everywhere you can think of, except the Antarctic. Okay. That's the only place there are any bats. The entire rest of the world, again, short of the very coldest North Arctic areas, are going to have bats in them. So they're extremely widespread. There's a lot more of them than you may have thought. We can divide them up into two main groups. And those two groups are the megabats, which include fruit bats, flying foxes, and the microbats. They're vesper or evening bats. We have all vesper evening bats. We do not have any fruit bats or megabats. The megabats are big. They can have a 5.5 foot wingspan. The little microbats, their bodies are hardly bigger than a mouse, and and their wingspan is maybe the spread of your hand span. So um, the the megabats, the big bats, are fruit bats. They eat fruit. They have large eyes, a long nose for smelling things. Meanwhile, the evening bats are all about the hearing. They do not have. They have small eyes, and they have large ears for their size because they depend so much on their hearing with the echolocation. And so they have adaptations for doing that. They have a large eyes, no tail to speak of. Some have tail. There's always exceptions to every rule of nature, but no echolocation. The big bats don't use echolocation. Now here in Pennsylvania, we have all microbats. So they eat only insects, and they do use echolocation to navigate and to find those insects. Now microbats get around a little bit. Most of them eat insects, but some have added nectar, some fruit. Some even will specialize in other in invertebrate animals. Maybe there's one that does fish. There's one that's especially adapted to eating birds. But none of those are in Pennsylvania. All of ours are insect eating ones. And of course, you may have heard about the vampire bat. So we have to say something about vampire bats. They are a microbat. They are in South America, though. None are up this way, Central and South America. There are three species of them. They are very specialized. And when we say they eat blood, that is all they eat. They are specialized to eat blood, which is not as easy as it sounds, because if you have a blood rich diet, you have a lot of iron you have to take care of. And so they have special glands to excrete the excess iron so that they can handle all that richness that is in blood. But don't worry about those around here. We don't have any here in Pennsylvania. We're all insect eaters. We should talk about rabies because that often comes up with bats. When we're talking about bats, this is the skinny on rabies. Do bats carry rabies? Yes, they do. About 5% of them do. Do bats give it to people? Yes, there have been documented cases of bats giving rabies to people. How often does it happen? 1 to 3 active cases of rabies per year, but that's from all sources, not just bats. About 60,000 people a year get the preventative shots, not the vaccine, but an exposure treatment that you can get. That if you have any chance that you may have come in contact with a rabid animal, you should get these shots. And there's a series of them, and so that is the cure, if you will. Once you get the disease, you are in trouble. Once you get the symptoms. In the U.S., though, the most common exposure is actually from bats, mainly because a lot of other vectors have been taken care of, like dogs and whatnot, have been taken care of. And people don't run into raccoons, for example, and many of the other mammals are just so secretive. But bats, one gets in your house. They're very numerous. One gets in your house or flies in through the attic or something like that. you could have incidental contact with one. And so it is the most common vector in the United States. But again, it's extremely, extremely rare that it does happen. So if you are concerned, have had any chance of physical contact with a bat, or really any unfamiliar mammal, then you should see a doctor about that, even if no wound is seen. There have been cases where people have contracted rabies and they didn't have any evidence of any physical damage on them, but they did wake up, for example, for a room with a bat in it. Okay, so even just saliva, even just a scratch from an infected animal can transmit the disease. So this is a particular concern, like if you see a bat flying around a baby's room or around an invalid's room, or you wake up and there's a bat flying around your room, you probably should go talk to a doctor, maybe get those rabies shots, because even incidental, just the slightest scratch can be a way of getting that contracted. So there is the prophylaxis shot that protects you is very effective, but you have to get it before you show symptoms. Once symptoms appear, it is fatal in the vast majority of cases. The number of cases where people survived it is like a handful, and they're like, there's whole literature about those studies, about the few people who have managed to survive an actual active case of rabies. So it is something serious, and if you're going to be studying bats, for example, you'll get the rabies vaccination so that you can study them safely. Let's talk about bat parts. What makes them special? What makes a bat a bat? And if you take a look at this photograph that I have up right here, or actually it's a drawing, you can see how the skin is stretched between the bones of the wing, and how they have like skin everywhere. Okay, everything that have any kind of webbing between it, between legs, tail, spread out fingers. It's got something there. And we can kind of see sort of another animal that has a similar situation, but a much more reduced kind of body build. That, of course, would be the flying squirrel. The flying squirrel has a patagium. Okay, so that tissue, that skin stretched between the bones, between the limbs, and so on, that's called a patagium. And flying squirrel has that. All right, so you can kind of see where this strategy, this body structure kind of evolved. All right, maybe initially these animals were gliders, and then from gliding came flapping, and from flapping came the bats. So our bat has the maximum patagium. A lot more. It's much thinner. It's much lighter, and they even have their bones of the bones of their hands have been, their fingers have been elongated. Okay, as we see in this one, and so all that webbing is between the fingers of their bones. It's different than it is in a bird. For a bird, for example, all those finger bones are gone. Okay, they just have kind of like a wrist stub out there, and all the finger bones are reduced, and everything is feathers. It's all feather quills. Okay, that form the structure of the wing. In a bat, his fingers are extended. The finger bones are extended to become the framework that the wing is on. And then they have a little secret, a little Swiss knife, if you will, a little extra bit, and that is the thumb. That thumb is very important. Okay, that little thumb is still on its own. It works. It's its own finger. It hasn't been enclosed in any patagium, skin webbing, because that thumb is what they have left to climb around on. They can hang on by their feet, but if they want to go up inside of a bat box or in a cave, they have to use their thumbs to climb up. Okay, so that thumb is very important. Another important feature, of course, of our cave bats, of our Pennsylvania bats, are the ears. And our bats have very large ears, and they have a tragus. And the tragus is that little tab that's in front of your ear. And it's very important for bats. It's enlarged in bats because it's part of their hearing system. Okay, that whole shape of the ear is specially designed to capture sound in the way that they need to be captured. And the tragus apparently is one of those features that it needs to have to gather the sound up in the manner in which it needs it. And what sound is it gathering? Well, it is gathering ultra high frequency sound, and that's the echolocation. So they pull out a pulse, and then they wait for it to bounce back. It's like sonar. Okay, send out a pulse, wait for it to come back. Except for bats, the pulses can be 100 or 200 per second. All right, so it is not just a bing and they wait for something to come back. It is a rapid fire set, and it gets faster as they zoom in on their prey. Now I have here I have the sound up. I hope it's coming through for you. This is a slowed down bat sound. And you can hear the pulses. Now it's slowed down to where we can hear it because we normally can't hear it. We normally can hear in the 20 to 20,000 hertz range. Bats are sending out these pulses in the 14,000 to 120,000 hertz range. So a little bit of overlap with our hearing, but only the very lowest pulses. And you can sometimes hear them chittering up in the sky at night. And you would think, well, that's maybe the echolocation, maybe those very lowest pulses are part of that. But the real important part, the part where they spend most of their time, is going to be above our range of hearing. So well above our range of hearing. And of course, this recording is slowed down. Let me show you an ultrasound of this recording. And you can see the shape of the pulses. And if you listen to the recording, you will hear it gets faster. And then there's like a at the very end, a little. A little buzz at the end. So echolocation is really doing two things. The echolocation, they're using it to know where they are in space, where the branches are, where a building is, where a tree trunk is, where another bat might be as well. Okay. And then they're also zeroing in on the insects. So they're navigating just from here to there in the sky using echolocation. And then they're also zeroing in on insects using echolocation. When they get really close to an insect and they have one in their sights, so to speak, in their path of travel, then the pulses get much faster. That's when they approach 200 pulses per second, and it comes through on the recording as a buzz. Okay, this would be a and all of a sudden, and that is called a feeding buzz, and that's when they are zeroing in on that insect. Now that patagium has another function. The stretch between their legs is called the uropatagium, and the uropatagium acts like a scoop. That is how they actually get the insect. They don't snap it out of the sky with their teeth. They scoop it with their tail and bring it up to their mouth and feed that way. So if you think about this bat eating hundreds of insects every night, every one of those is a scoop it up and put it into the mouth. That's the main function, the main way that they eat. Now, bat vision, you may have heard, oh, bats are blind, or the expression blind as a bat. And you probably know that's not actually true. Bats are not actually blind. They do see. They do not see in color, though. There are rods and there are cones in your eye. The rods see light. and they translates to black and white. And the rods see color, excuse me, the cones see color. So cones are color, rods are light and dark. And they have lots and lots and lots of rods, but very, very few cones. It's interesting, though, that some of their cones, the ones that do have cones and the cones they have, uh, many of them are sensitive to UV light, which we can't see. And that may be helpful in the receding light of an evening sky, that, you know, there's some wavelengths coming up as the sun sets that kind of help them out. They come out as soon as the sun sets. And so even if there's a little bit of light in the sky, they're beginning to feed, and they're taking advantage of just that last little bit of ultraviolet light that might be around, or so goes the theory. Let's talk about the bat's life cycle. What are they doing right now? Well, right now they are mating, and they are flying off to their winter hibernacula. Okay, they mate in the fall. They fatten up in the fall, and then they head to their caves to hibernate. Now, I'm talking about here are cave bats, and we'll see as we go. We actually have 6 species of cave bats, but we have 3 species of migratory forest bats, okay, that migrate. So the ones here on this calendar, these are the, I'm showing you the hibernating ones, okay, and they stay in Pennsylvania. They just retreat to a cave, and that's going to be there where they hibernate before they go in to hibernate, or they're otherwise, if they're migratory bats, they're going to fly south, okay, and hibernate somewhere in the southern states, or maybe even in Mexico. But before they go, as they're getting ready to go into those caves, they mate, but they don't actually get pregnant. They don't fertilize the eggs. They have a delayed fertilization. The female holds on to that sperm until the time when fertilization occurs, and that happens in the spring. So when they emerge in the spring, and after they've fed and kind of gotten themselves back on their feet, so to speak, then fertilization is going to take place, and they're going to start raising their pups at that point, which is very interesting, I think, to be able to delay that. That's all part of their survival strategy. They don't want to be trying to grow a baby while they're in hibernation, because that hibernation, they want to use the least amount of resources of energy as they can. Okay, so here they are hibernating, gathered up in a cave. None of them will be pregnant at this point. They'll all be just waiting for the spring, but they're going to get through the winter with whatever reserves they have clinging to the ceiling of this cave. They want it to be cold. The colder, the better, because if their body will chill, their metabolism will slow, their heart rate will slow, and then they will use very few resources, very little body fat to get through the winter. Now, these are not large animals. They're tiny bodies. As we said, we're talking about a mouse-sized body. They have to get through 4 or 5 months of time without feeding, okay, on those little bodies. So there's not a lot of leeway there, and we'll see that becomes very important here in a few minutes. Speaking of the pups, bats are long-lived, but they're very slow to reproduce. Most bats only have 1 pup a year. There are a few, like the red bat I'm showing here, that sometimes can have 2 or 3. So again, there's exceptions to every rule, but the rule in general for our bats is that they only have 1 pup, maybe 2 in some species. Again, the exception would be more than that. So they're long-lived. We're talking 6 years, which is a long time for a tiny little mammal, but there have been evidence of some maybe in the 10 to 20 years old. So they are long-lived for such a tiny mammal, but slow to reproduce. Now, when they go out to do their summer life after they emerge from their hibernaculum, from their cave, they're going to be going into their summer maternity colony. The males and the females split up. The males go off and they roost by themselves, or maybe small groups somewhere, just coincidentally, not by any kind of intention. They hang out with other males and singly in other places. But the females, in many species, again, there's exceptions to all these rules, but most of the species will group up and they will raise their pups together. If you have a bat box, you want a bat box. If you want a bat box, you want a lot of bats, you are trying to attract a maternity colony. You're trying to attract the females and the pups. So, and those can be quite large. Hundreds of bats can be in one of the thousands sometimes in these in back in the day. Things have changed a bit for our bats, but yeah, the thousands, hundreds could be together. So if you're doing a bat box and you want significant numbers of bats, you want to attract a maternity colony, and that's going to be a large box. And here they are, kind of all wedged in there. They all like it tight. They like it warm. They need it warm to raise their babies. The warmer it is, the faster the babies grow. In fact, they like to be able to move up and down in that box to find just the right temperature for their babies to have the maximum growth. They got to grow fast because they got to grow fast enough to fly, and that's going to be when they're adults. And then they're going to be out there feeding and need to be living their lives once that takes place. So they grow quickly, and they are out and flying around by the end of summer. Now, we need to talk about white nose syndrome, which is an unfortunate fact for our cave bats especially. White nose syndrome is a fungus that infects bats while they're in their caves. It's a cold-loving fungus, so it's very difficult to eradicate. It's happy deep in those caves. And it's one of its first symptoms is to form a white fuzz around the muzzle of the bat. That's why it's called white nose syndrome. Now, if it can get really going, it can cover the bat, all right, if it really gets a head of steam up. But that is not actually what is the most dangerous for our bats. This, of course, as you see here, that's pretty rough. That bat is going to have a hard time surviving. But even with less than that, this white nose is very dangerous because what it does is it just kind of grows on any skin of the bat. And this is, you can see the white here is the fungus that has grown on the wing of the bat. And then if we show it under a black light, you can see iron deposits. That's places of tiny wounds. That is where blood is coming to the surface because of the fungus. So the fungus is actually damaging the skin of the bat. It's taking nutrients directly. But the biggest threat, what really ends up killing the bat, is not even this, it's the irritation that wakes up the bat. So they're fighting off this fungus. There's energy and resources that the fungus is extracting from the bat, but then the bat is being disturbed. It's painful, apparently. And so the bat wakes up. And remember, we said this little tiny bat has to do all of its feeding. In fact, it doesn't even want to get pregnant during the winter because it needs all its resources to stay alive. And if it's awoken by this disturbance of white nose, then these bats start to wake up. They wake up too early. They burn off their fat reserves. They start to fly around the cave. Sometimes they'll even leave the cave. And when they leave the cave too early, what do they find? They find nothing but snow, bare branches, no insects, and they die. The last desperate move is to fly out of the cave because they're literally starving to death because of the white nose fungus. They burned up their energy trying to, being disturbed by the fungus and so on. Back in the day before white nose was the big thing, there was a lot of concern about just humans going in and, rummaging around, going caving in these, or just looking around, bothering these bats in their hibernacula. And that alone was enough to cause concern. You rustle up all these bats and they burn up their energy and they can't survive. Well, this white nose syndrome it's not just one human walking in on a January morning. It is a problem for the bat the whole time. And it's irritation for the bat. And so they end up dying because of that. And it hits every bat in the cave. Okay, so there have been, and it's been tremendous loss. 99% in many of these species have colonies have died off. Okay, so you may have had a colony of 50,000 bats. Okay, maybe 50 are left. All right, just the total decimation of these bat populations when it gets into a cave. So you can see here where white nose has been going. This is the latest as of 2025. It first was confirmed in 2006 right here in eastern United States, up in New York. It has spread. If you look and see where the red circle is, I don't have a red circle. Wait a minute. There it is. The red circle, those are this last year where they have confirmed the presence, or at least strongly suspected the presence of white nose syndrome in those. So you can see the white squares, the light blue squares, they get darker. And then the last 4 or 5, 3 or 4 years are the yellow, the orange, and the red ones. So you can see out west, it's already been in the east for a long time now. And it's probably affected every hibernaculum anybody has ever found now in the east. And it is working its way across the west now. So this has led to some endangered designations. So prior to white nose syndrome, the Indiana bat, and we'll talk about all these species in a few minutes, was federally endangered already because of habitat loss. In 2019, due to white nose syndrome, I mean, the Indiana bat's been on the list since the beginning of the endangered species list. In 2019, they added the tricolored bat, the little brown bat, and the long-eared bat to the state endangered list. The long-eared bat has been added to the federally endangered list. The tricolored bat is proposed to the endangered list. And the little brown bat is under review, okay? And which is probably the most shocking of them all, because the little brown bat formed the largest colonies of cave bats. Maybe, tens of thousands in a bat cave hibernating, okay, for the little brown bat. It was the most common bat. And again, numbers decimated to just a single percentage of what they were. 1 to 2% are still alive. The Pennsylvania has added the small-footed bat to the PA threatened list, although it's not on the federal endangered species list yet. So as you know, state and federal have their own lists, because state is talking about populations just within the state. Federal would be populations for the whole country. Sometimes we have an animal that's not all that common, and so it becomes endangered in the state because it's just, maybe it was never that common to begin with, even though it might be healthy in other places. But still, it's a concern for the state, and we put state resources toward it. Not on this list is the big brown bat, which has luckily not had the same level of damage. It's down to maybe 40% of what it once was, as opposed to maybe 1 or 2%. So it's definitely been hit, but not nearly as hard as the other bats have been. And our migratory bats, which again, we'll talk about these species in a moment, of which there are 3 species, they're not affected by white nose because they don't spend much time in the cold caves. The fungus likes cold caves. The migratory bats go south, and so the effect there is not as much. And they've been shown to carry it. They found the spores on them, but they haven't really found any evidence of loss of numbers due to white nose syndrome. Habitat loss and so on continues to affect all of these bats, even without white nose. It includes those migratory bats, but at least white nose has not been a factor for them. So what do we do? What's some responses to white nose syndrome? I'm giving you the quick version of all of this. We could spend an entire program on white nose syndrome at some point. Get an expert in here on that. I'm just giving you the quick rundown that I've learned. So what are some responses? They've been doing things like spraying with the fungus with food safe sprays. They probably would not do that in a wild cave. They don't want to disturb the habitat of a wild cave because of other things that are in the cave as well. But they have tried this in, say, mines or closed transportation railroad caves that have a bat population. They figure those are ones that are not quite as natural, and they feel a little more leeway to try some things. They've tried decreasing the temperature in the cave. When they seal up a cave, for example, to protect the cave, which they often do, they'll seal the cave up to keep people out. And that at least gives whatever bats are left a chance to keep going. But they'll be careful about how they seal them up. They'll try to keep the airflow in such a way that it keeps the temperature as cold as possible in the cave in the winter, because that slows metabolism down and that helps those bats get through the winter. If the cave warms up, when they warm up, they start to burn more resources. It's kind of like counterintuitive, right? You think, well, when they're cold, they would burn more energy up. No, when they're cold, their metabolism slows, and so they don't need as much energy. When things warm up, their body warms up, they start burning energy. Okay, so keep the cave cold. And fattening up bats with good habitat before they go into their caves. All right. So making sure we have good insect populations for these bats as they are approaching their caves. And if you know anything about here at the Audubon, we love to talk about native plants, and we love to talk about how important those native plants are for the insects and how those insects are important for the birds. Okay, so the bats love them too. The fatter the bat, the better chance it has of getting through the winter, even if white nose is present. They're continuing research in genetics, natural enemies, vaccines, and so on, but it is a difficult to deal with because of how many hibernacula there are, and just a lot of practical issues in anything, in any of these solutions. Here's the hope, though. Here's a little bit of seems to be, is dealing with it better than some of the others. Our 3 migratory species are not significantly affected, and we'll go through these in a minute. In recent years, monitored cave bat populations have stabilized. They're very small. There might be just, 1,000 bats or 500 bats in a hibernaculum which had 50,000 bats, but those small populations appear to be stable and slowly growing. So this white nose syndrome is present in Europe, but their bats don't seem to be as dramatically affected by it. In fact, we think that's might be where it came from, is from Europe. And so there is a chance of adaptation. And the bats that are left, even though they're small, there's hope that those bats are adapting and that they will be able to eventually recover. Although the time scale to get back to tens of thousands of bats in a hibernaculum with their slow reproduction rate, we're talking like 1,000 years. Yeah, hundreds of years to get back up at the rate at which they reproduce now. But stabilized, slowly increasing. We'll take any good news we can get. But then we talk about windmills real quick. You may have heard about bats and windmills. Do they take out bats? Yes, they are a significant, they do significantly damage bats, where, of course, where the windmills are at. And in this case, where our cave bats are struggling with white nose syndrome, our migratory bats, unfortunately, aren't very good with windmills. They're the majority of the bats that are struck by windmills. So how can you save the bats from windmills? Well, simply turn them off, turn the windmills off when the wind speed is slow, because that's a typical time when bats are feeding. When the wind is slow, because they're trying to catch insects. If it's windy out there, then the insects are going to have a hard time catching up to the insects. The insects are going to hunker down too. But when the evening is calm and there's not much of a breeze, the bats come out. If that windmill is turning, that is when most of the fatalities are going to happen. So turn it down in low wind conditions. This does result in a loss of energy production. And to help minimize that, there's a firm out there that has developed bat detectors. They detect the sound of the bats, the ultrasound of their echolocation. And when bats are detected, then they shut the windmill off. So if the bats are not in the area, they can turn the windmill back on and still get energy from it. So again, trying to find some way of getting all these pieces to work together. And there is positive news in that regard. All right, let's talk about our bats. And introduce you to our 6 hibernating cave bats and our 3 migratory forest bats. We have 6 cave species. These are ones that hibernate right here in the state and do not leave. They do not migrate. They disperse for their feeding and for raising their babies, but then they congregate again in caves, tunnels, mines, okay, rock crevices, okay, right here in the state. So bat species number 1, the eastern small-footed bat. All right, this is my favorite bat because he is the smallest bat. This fellow weighs 2 pennies. That is how much this bat weighs, as much as 2 pennies, just a couple of grams, okay, which I find is just absolutely amazing. His wingspan is just as wide as your hand, all right? So we're talking like, you know, the smallest bird size of sparrow or a chickadee would have about a wingspan about that much. Okay, so very tiny. He's called the small-footed bat because he has a small foot. Okay, there you go. He's a small-footed bat, our smallest bat. Now, when we say smallest, none of these bats are more than a few grams. Okay, so on average, he's on the smallest, but you're going to get some overlap between these. It's a bit of an artificial category because they are so tiny. The tricolored bat. All right, this is my favorite bat because each hair shows 3 colors at the same time. Okay, so here you have the banding on this close-up photograph. And that banding gives you an idea of why it's called the tricolored bat. Now, not much is known about the tricolored bat and its feeding habits. That's a big mystery for a lot of these. We know a lot about big browns and little browns and Indiana bats because they have these huge hibernacula. Some of these other bats will be dispersed among the big browns and the little browns and the Indianas in one, but some we're not sure where they go. Okay, we find them in just small numbers here and there, and not in the huge colonies. And so a lot of them, we just don't know a whole lot about their life cycle or their feeding habits or their distribution. They're just too secretive, and they don't cooperate with big hibernacula in quite the way that some other bats do. So a lot of what we know about these is just a little bit. Okay. Now here's our big brown bat. This is my favorite bat because one of his favorite foods are cucumber beetles. And I like cucumbers, I like pickles. So I like anything that's going to keep our pickle crop happy. And this is our big brown bat. He is not endangered, but again, he has experienced pretty small, pretty large losses. He's probably doing okay because he's really, again, our largest bat. Okay. Of the cave bats. We have some other bats that are bigger. The migratory bats, a couple of those species are bigger yet, but the big brown is the biggest of our cave bats, and having that extra body fat may be a capacity for body fat, maybe how they are not as, more of them are able to withstand the disturbance of white nose. So how big is the big brown bat? Well, we just said that the littlest bat, the small-footed bat, is only about as wide as your hand span, but big brown bat gets to be about 12 inches. Okay, so about as wide as a ruler. That's his wingspan. So he is our second largest bat. We'll see our largest bat here toward the end. All right, this is the Indiana bat. This is my favorite bat because I went to grad school in Indiana. I have fond memories of being in Indiana. Not Indiana, Pennsylvania, but Indiana, the state. And Indiana is where the largest of these hibernacula were for this one. He's been on the endangered list for a very long time because of disturbance to his hibernacula. And here is an Indiana bat in flight. Okay. But I want you to know something. You see all that pebbly texture behind the bat? That is more Indiana bats. All right. So that entire frame is crammed full of little Indiana bats looking at you. You know, it looks like the pebbly leather of a leather bound book, but those are all Indiana bats, all tightly packed together. They're probably not that tightly packed anymore, unfortunately, because of white nose syndrome, but that's what they once were. Here is the natural range of the Indiana bat. They have a large range, but they had a habit of being in really large groups for hibernating, and really just a few places. There's only a couple of places in Pennsylvania that had any Indiana bats overwintering. The vast majority were in Indiana. As I said, he's been on the endangered list since the endangered list was a thing. Here's a northern long-eared bat. This is my favorite bat because he has the longest ears. And why does he have such long ears? Okay. Well, notice the tragus in this one, that little tab that's in front of the ear. All right. He's got a big one of those and really big ears. Why such big ears? Well, here's why he does big ears. Okay. Let's talk about the echolocation arms race. Now, one of the things that's being eaten when these bats are on the forage are going to be moths. And moths are a nice prize for them because they're fairly large as opposed to all these little mosquitoes. It takes a lot to fill your tummy with mosquitoes, but a couple of fat moths, well, that's a little nicer. Okay. Well, the moths do not want to be eaten either. And so shortly after the bats evolved echolocation in the fossil record, moths evolved hearing to hear the high pitches of the bats. So the bats got echolocation. Wow, we got them now. And then the moths are like, oh, not so quick. And many of those species have learned to detect the presence of the bats. And they can hear the bats. So they've evolved to hear echolocation frequencies, and they will respond with evasive flying. So they might drop out of the sky, or they might, fly sideways suddenly or something like that to try to get out of the path of the bat that's coming for them. There's even some species that have gone further to be able to make a sound. The moths will click. Okay. And the clicking could be warning the bats that they taste bad, or sometimes they're just pretending they taste bad. They're mimicking the bad tasting moths. They're saying, yeah, I'm clicking because I'm poisonous too, even though they're not actually poisonous. And that can warn the bat off. There's even one species that clicks in a manner that jams the echolocation of the bat. And it's a species out in the southwestern United States. This particular moth. So you don't have this particular moth here. So now there's an arms race going on, right? This echolocation, you think of as, the secret weapon that you're going to use to eat all these moths. Well, it turns out that the moths are developing defense. So what does the long-eared bat do? Well, the long-eared bat gleans its prey from twigs rather than echolocating the prey. Now, he does use his echolocation for positioning, for flying through the branches so he doesn't hit anything, okay? But then when he goes to feed, he will land on a branch, walk along the branch, and he will scarf up the insect that way instead of scooping it up out of the air, okay? And those extra big ears are going to help him hear the presence of prey on those twigs. Meanwhile, the moth has put all of its evolution points into hearing high pitches, okay? The high pitches, the ultrasound frequencies of the bat echolocation. They don't hear low sounds very well. And a bat creeping along the twig, just making those slightest little bit scuffling noises, those are going to be very low frequency pitches, okay? And the moth doesn't hear the bat coming. And there was a study out that tested this, and they determined that the moths had a hard time hearing the approach of a bat that gleans from the surfaces. So not all bats do it the same way. They developed this echolocation. Now I've gone back to the old method of just walking along and eating something when they find it. So that's the echolocation arms race. Now we have the little brown bat. This is my favorite bat because this was the one for a couple of reasons. One, it was the largest colonies, biggest winter colonies of all of our Pennsylvania bats. The Indiana bat makes big colonies, but not Pennsylvania. In Pennsylvania, our big colonies were these. Okay, of course they've been decimated. Another reason why this is my favorite bat is because here's a shot of Canoe Creek in the summer of 1994, so a long time ago. And this is not their winter location. This is their summer location. So they wintered in a cave, in a mine there out in the park. And then a number of the mothers and babies would go to roost in the attic of this church, this old church. And they protected that church and preserved that church as a summer maternity ward for these bats. And this is the naturalist at the Canoe Creek climbing up into that little hole. All right. And that's where the bats are coming in and out of. Okay. And they go in the little hole and climb in a little hole. Back in 1995, I got to climb in that little hole in the summer. And I walked around inside of that maternity ward. And there were bats all around, and they had big baffles, vertical surfaces, extra, partitions and things put up in there. So there's lots and lots of vertical space for the bats to do all of their raising of babies. And I got to walk around in there. You walk in your hands and knees, you get to squish the bat guano. And then when you get back to the hotel, you take a really long shower to get that all back off of you. But yeah, so little brown bat, I got to see them up close and personal crawling around inside of that hibernaculum that you see there. Now it brings us to our 3 forest bat species. These are all migratory. They're called forest bats because they have a habit of feeding in the forest. Not really all the bats we have, the cave bats will feed in the forest, and some, they feed out in the open and so on, again, from various species. And we don't necessarily even know exactly what the preferred habitat of all of some of those lesser known species are. But the forest bats are identified as ones that prefer to fly around the forest. The red bat, for example, likes to fly along streams, okay, and catch insects in the little channels, little tunnels of trees that are hanging over a stream. He'll fly up and down that stream bed, and he'll catch insects that way. So this is our 3 bats, and 3 migratory bats. Again, they don't winter here in Pennsylvania. They don't even hibernate as far as we know. They fly south and keep doing their thing, even in the winter. This is the red bat. And this is my favorite bat because of the way he uses his tail like a blanket. You can see he's got himself kind of tucked in there. I've got another shot. This is of a taxidermied specimen, but you can see the super furry tail. Now, our cave bats don't have these furry tails. Okay, they just have skin tails. All right, but this red bat, he has a luxurious, fluffy blanket of a tail, and I think that's really cool. Here's a photograph that I took of a red bat at Beechwood that I encountered one day. I was taking a group of school kids around, and I had stopped at an oak tree, and I was showing the kids the galls on the oak tree. And I'm like, saying, hey, look at these galls. And I'm like, oh, there's a bat right there. And lo and behold, I went back and took a picture of it. There was a bat just hanging out. Now, this was a mid-October day, and then it snowed, got really cold that night. Okay. And I'm like, oh my gosh, this poor bat. What's he going to do? I mean, he can't survive. He's going to freeze to death, whatever. Well, I've learned more about them. This is where I've learned about red bats. Red bats have a little adaptation that they do. When things are going to get cold and they haven't migrated south just yet, they will drop into the leaf litter, and they'll just insulate themselves right there in the leaf litter. They can go into a torpor, which is kind of like a very light sort of hibernation thing. Their body temperature slows down a little bit, but not a whole lot. not to super hibernation levels, but enough to conserve some energy, get through the night, and then continue their migration in the morning. All right, this is the silver-haired bat, number 2 in our 3 migratory forest bats. This is my favorite bat because he has hair like mine. A frosty. He's frosted like me. I didn't used to be frosted, but I am now. He's migratory to the southern United States. Okay, so this is his range. All right, and this is his year-round range. If he doesn't stay here, this is not his winter, doesn't show his winter-summer range. It just shows his range. Okay, in the winter, he's going to move to the southern parts of this range. In the summer, he's going to spread out into the north. Why does he not just stay in the south? Well, it's the same reason why all the birds just don't stay in Florida all summer long, because they got babies to raise and they're going to need more resources, and they can get through the winter together, but there's too many of them to get through the summer and raise babies. So they spread out. The birds do that. And these migratory bats do too. They leave the south, spread out to give themselves some elbow room to find enough food and so on to live their lives before they head back south to overwinter. Now, so that's the silver-haired bat. And then our last bat for the evening, the hoary bat. And the hoary bat is our biggest bat. He's bigger than the big brown bat, and he is 2 hand spans wide for his wingspan. So he's a pretty good sized bat. Hoary bat, where does that come from? Well, hoary frost, that refers to like the really, really heavy frost where the ice crystals actually kind of like form little needles and cover the vegetation. That's a hoarfrost. And so we said the silver-haired bat kind of had a silver coating to his hair. This guy has a more pronounced frosty look to him. He's kind of got brown underparts instead of black underparts. Like we saw the silver-haired bat, that was more of a dark brown underparts, and then that sprinkling of silver across the top. This guy has white on the top, same as the silver-haired bat, but he's more brown underneath. Okay, so they're both kind of in that, have white tips to their fur. Now, here's what I think makes this my favorite bat. Favorite fact about this bat is when we say this one migrates, we mean this one migrates. Okay, none of this, oh, I'll just go to Texas for the winter. This fella goes all the way to South America. Okay, Central and South America. So he is a serious migrator. The hoary bat is a serious migrator. So let's talk about some wingspans, just to give us some kind of review and perspective here. Our small-footed bat is about 1 hand span wide. Okay, that's our smallest bat. Big brown bat, okay, is about 1 foot wide. Okay, a hoary bat is 2 hand spans wide. So you're talking about as wide as like a full keyboard. Okay, so now you're getting some pretty good size. It's a pretty good size thing. If you had a bird that big, you'd be respecting that bird, because that's a pretty good. That's like a robin-sized body on there. That's a pretty good sized animal. Okay, in the hand, we can see a difference in their sizes. The Indiana bat is one of our smallest. Again, there's some overlap in what the actual smallest one is. There's the Indiana bat in the hand. Look, he's hardly bigger than the guy's thumbnail. His head is hardly bigger than the guy's thumbnail. The hoary bat, though, he's a handful. Okay, you're gonna, he's got to fill your hand up, not just by the fingers. You're gonna hold him with your whole hand. So he's a respectable sized bird, or bat rather. Then we have the a graphic here that shows you how our microbats compare to the biggest of the bats, and that would be the megabat, the flying fox. And that bad boy has the wingspan nearly approaching that of an eagle. All right, so 5.5 foot wingspan. That's some serious bat right there. So our microbats don't have anything on those big flying foxes. If you have bats in your belfry, what are you going to do? Okay, what do you do if you have bats taking up residence in a place where you don't really want to have them? in the spaces of the attic of your house or something like that, where they're causing a mess or getting in a concern for you. Well, if you don't want them in there, and again, you may not want them in there because they're going to be messy. They have guano. You don't want them flying around the house because there's always that risk of exposure to a rabies or something like that. So you really want to kind of have them in a safe place on their own. How do you get them out? Well, if you're thinking about getting them out, the most important consideration is make sure you do it at the right time. The time not to try to get rid of them is in the summer. So if you want to just exclude them, close them up, keep them out. So you want to close up the hole that they're coming in and out of. Don't do it in the summer because you might trap babies or sleeping bats in there, and you don't really want to do that. Okay, you're going to cause yourself more mess, and it's not humane. So humane exclusion would be to wait until the pups have grown, they have left the maternity colony, or over the winter while they're hibernating, but you don't have much time in spring, because as soon as it warms up enough to get some insects flying around, those bats are going to be out. They don't wait around a lot because they are going to be hungry and ready to go out there and feed as soon as any insect populations begin to get some size to them. So, and once that happens, they're going to be heading for their maternal colonies. They're going to become pregnant, and they're going to be raising their pups. And you do not want to trap them while they're in those colonies. So anything you do it in the winter, so you don't damage. Just deal with them for the summer, live with it, and then in the winter, take care of closing up that for them. What can you do to make sure that you don't trap any of them in there? Well, give them one-way tubes is one thing that you can do, so that they have to go out. They can go out the tube, but they can't. If they put a little cloth or something at the end, they can find their way out, but they can't find their way back in again. This might be helpful if you have like a roost where you're just getting some solo males that want to go up in there a lot, as opposed to a big maternity. If you have a maternity colony and you keep the adult bats out, you're going to strand the babies. You don't want to do that. But if you do have bats in there and you're trying to get them out, this is one humane way of doing it. But again, I'd be really careful with this one. I really only want to do it when in the winter anyway, okay, because I don't want to have any chance of trapping them in there. And best practices would be, if you're going to exclude them, what can you do to provide alternative housing? So let's talk about bat boxes real quickly. The best designs are the big ones. Why? Because the big ones are going to attract the maternity colonies. All right. Small bat houses, which look really cute, unfortunately, they're not going to attract very many bats, because the bats they want to be together with a lot of bats together. Okay. So a small house is going to have a few individuals in it at most. If you want any size of population, if you want to attract bats because you want to have for your mosquitoes, or if you want to provide the best possible habitat for a bat because you're concerned for bats and want to make sure they have the best they can have, you want a big box, a big maternity colony, like a 3 foot by 3 foot, 2 foot by 3 foot size box. And you might want to size it for whatever colony that you're moving. Okay, so if you're moving a maternity colony, put a bat box nearby that's going to match what they have lost. Now, so the bottom line here is bigger is better. Inside, you'll find baffles. You can kind of see them in there, okay? Because you're going to add layers. The bats don't need much horizontal space. They like to be tight. They like it up in there in tight spaces. That keeps it hot. That keeps their babies safe. So there's baffles inside. It's not a big open cavity on the inside. So baffle gives you a lot more bat space for a relatively small box. And an open bottom, that's how the bats are going in and out, with a landing plate on the bottom too. Okay, a roughened landing plate. Give them something to hold on to, not just smooth sawn lumber, but something that's got some grooves in it so they can climb up with their little thumbs and get up into that colony. So there's some aspects of it. You can see some other things too. There's some good designs that you can get online. The Game Commission has some recommendations as well. You want it in a sunny location. You want to paint it black because the bats like it warm. This is the Rocket House, which is kind of a simpler bat house that some people have designed and put up. These are good for males, for small groups, for mixed species. They're not as valuable as the big maternity colonies are. Better than nothing. If you want to put one up, great. Okay. But just bear in mind, it's going to be for individual small groups, and it's not going to be housing a lot of bats. So again, the bigger the better when it comes to bat houses. All right, there's my rocket. There's my rocket. Sorry, this just got hit behind by one slide. There's a picture of the rocket style house, which again is on the small side, and is not going to house very many, but it can be useful if you want to provide alternative habitat for a small group of bats that might be hanging out where you don't want them, or you just want to have a place for bats. Bigger is better, but small is okay too. Placement, direct sun. Bats like it warm, especially the maternity colonies. Freestanding is best on its own pole with a predator guard. You can put it on the side of a building, but you are exposing well, you kind of limit a little more of the sunshine to a certain extent, but you're also, it's easier for predators to climb the side of a building than it is to climb a pole with a predator guard on it. So there can be predator problems. Here's an example of one in action. I took this photograph at Beechwood. We have a building that has some louvers on it, and some bats were living in there. They formed a little colony in there. And unfortunately, a black rat snake was able to climb this building, went up the side of this barn-like building, and he started munching. Okay, and he disturbed the colony, and the bats never returned after that disaster. So I don't begrudge the black rat snake. He's doing what black rat snakes do. I like snakes too. But I really don't want to, I'd rather the local snakes find something else to go eat rather than the bat colony. So if you put on a bowl, you're going to have less of that kind of thing happening. Raccoons will raid bat things as well. And owls can too, but owls and other opportunists just running across it, they're not going to be big predators of the bats. Just incidental kinds of things. If they happen to come across it, they will, but it's not going to be a big part of their diet. Even bullfrogs have been known to catch bats, and I would just call them opportunists as opposed to something that is making a habit of eating bats. So if you want bats, what can you do? Well, we talked about putting up a bat box. All right. Now, the thing about bat boxes is that just putting up a bat box, a lot of people are disappointed because they put up a bat box and the bats don't come. The best bat boxes have been in a place where they are near an existing colony. The bats are they're not really excited about new things. They're very conservative, all right? They like to go where they've always gone for the last, 10, 20, 100 years, okay? Maybe 1,000 years in the case of a cave. And they don't quickly move to new locations. They're not very flexible in that way. If you exclude them from one spot, putting up one nearby, those have been successful. Just attracting bats, if you don't have a bat colony nearby already that's already burgeoning and needs more space, well, it can be a long wait until you get a bat. But in the meantime, if you want bats, the bat box is great, but what you really need to have is good habitat for the bats if you're going to have any chance of having bats at all in your house, in your bat house that you've made, or just in your yard because you want bats for insect control, or just because you want to be a good steward of the natural resources. So if you want bats, what can you do? Well, this is the thing you can do. Favor native insects, okay? Favor native insects. Anything you can do to make insects happy will make your bats happy. It'll make your birds happy too, for you Audubon members, okay? And many other animals, because those insects are going to form the foundation of a significant part of our food chains, including the bats. So save a space for wild habitats. All right, leave a corner. Got a wood lot, don't manage it to death, just let it do its thing. Okay, maybe take out the invasives, but leave the leaves. Don't rake everything up. Let put some brush piles out. Anything that helps native insects is going to help the bat populations and everything else. Okay. If you're going to be doing some planting or planning, then plant native species because they're going to have the best, strongest associations with native insects. Okay. And then, everybody has to deal with problems when you're trying to plant things. So integrated pest management, which is there's a whole world you can get into there. But that's the phrase for basically you reach for the bottle as an absolute last resort. Okay. So reach for the spray, reach for this foul smelling chemical from Home Depot. That's going to be your very last resort. Everything else you can do to not do that, that would be like, keeping your plants healthy, proper watering techniques, how to mulch, soil amendments, all those kinds of things, to make your plants as healthy as you can, will reduce you're dealing with pests. Okay. Selecting the right species for your location and so on. That's all integrated pest management. Okay. Anything you can do, and any spray. And of course, if you're going to use sprays, they're going to be extremely targeted, very limited use, and all those best practices that you would use for any kind of chemical application to help your landscape out. Okay. So any of those things, anything that helps native insects is going to help the bats as well.